Well, good morning, everyone. Welcome to the Humanists of Greater Portland. I'm Pete Barquette. Humanism is a way of life that guides us to lead ethical lives and to do good without relying on the supernatural. It is a rational philosophy that encourages the use of science, reason, and free inquiry. Humanism promotes principles of social compassion to enhance the quality of life and to contribute to the well-being of society. Maria Bednarz is going to be our reader today.
I have a summary of article Financial Diplomacy from the Economist magazine, issue October 4th. This project supposed to be presented 1 month ago to be updated, with time, but I didn't have an opening. So America's international assistance has not been destroyed. It has been transformed. Nobody expected President Trump to save another country from financial crisis. Yet on October 14th, he met Javier Milei, Argentina's president, and an ideological ally to discuss the details of a rescue package. America has already promised Argentina a swap line worth 20 billion in order to address investors' fears about currency reforms and peso stumbling. The mega billions gamble was in President Trump's America First, despite domestic objection. Mr. Trump overhauled America's financial diplomacy and is extending the most generous American bailout in 30 years. Treasury officials said that Argentina may be the first of several bailouts from America on similar terms. For decades, policymakers used to alleviate poverty, and cash was doled out via aid agency, International Monetary Fund, and World Bank, in which America is the biggest shareholder. A new approach is emerging. American financial diplomacy is now self-interested. Money is on offer to ideological allies, leaders who control something Mr. Trump wants, and countries he hopes to lure away from China. Iowa soybeans farmers are feeling frustrated after China buys Argentina's 7 billion metric tons of soybeans, leaving U.S. farmers sidelined. America asked Milei to stop selling soybeans to China. We don't want a state led by China in Latin America. This is strategic policy of U.S. to further promote interest across the region. This is strategic policy of U.S. to further promote interest across the region. America's Treasury Secretary Scott Bessent wants the IMF to cut overall lending and help America reduce the trade surplus of China, which is another shareholder. China is the world's biggest bilateral creditor. It has spent 185 billion since 2016 on bailouts alone. This creates problems during tariff negotiations. Countries indebted to Chinese creditors hesitate to place tariffs on China. Foreign loans of 2 Chinese banks were worth 500 billion. Mr. Trump will be able to offer less, 300 billion for loans. Running a lending program to rival China would be alone harmful. Officials hope that bailouts and anti-China handouts may be dropped in favor of mining projects. If not, the White House would become a bigger donor than under Joe Biden, not something MAGA types would enjoy. Thank you, that's the end. I am sorry about
And now I'd like to introduce today's speaker. He has been an instructor of soil science at OSU for over 20 years, is the founder and faculty advisor for Oregon State University Organic Growers Club, which includes OSU's student farm. He supervises over 300 student volunteers at the OSU farm and secures funds to support the farm by selling the produce grown there. Please give a warm welcome to James
All right.
Cassidy.
Yeah. Okay. Hey, everybody. You can turn me down just a little bit because I talk super loud. Let's see, how do I get to my slides? Not that it's super important, but there we go. Yeah. So anyway, yeah, I teach at Oregon State University. I've been doing that for about 20 years, teaching undergraduate courses in soil science and in sustainable and organic agriculture. I'm also the founder of the student farm 25 years ago. 3 students complained, as is their job, that they weren't getting any organic anything in any of their coursework in horticulture or crop soil science, which is my home department. And I went to their first meeting. They thought, well, we should do something about that. And so I went to their first meeting and I said, we should start our own damn farm. So we started our own damn farm. And they're long gone. It's 25 years ago. They have mortgages and boat payments and everything. And I'm still here at Oregon State University. I've been running the student farm. In fact, I'm skipping my Sunday morning work party to be here, but that's okay because we have a Thursday evening work party every Thursday night, 4:30 to dark, hot supper served at around 7 o'clock. It's too dark now on Thursdays at 4:30, so we have the kind of the winter off for Thursdays. But Sundays we're year round for the last 25 years. Sunday, we call it Sunday school. It's spelled SKOOL because it's not school. It's just us on the planet and as humans, and we're squatting on the land there. And the university is squatting on the land, and the people, early days, people tried to shut us down in the department. They were kind of threatened by us. I don't know. They were, they're on the gravy train of grants and stuff, and they actually tried to throw us off of there a couple of times, and we just kept coming back, and they never came out. I mean, really, I've had very few people ever come out other than the students, and all the people who try to get rid of us are either retired or dead. So I love to tell that story. So students love that one. I said, be careful though, you're gonna be the sooner or later you'll be the man. So so look out. So yeah, I've been doing that. That's kind of like the work of my life, to be honest with you. 25 years, and I'm a volunteer myself, and we've had over 30,000 students come to the student farm, and we're completely self-funded through the sale of fruits and vegetables. And this is like a typical CSA box here. Say in July, or maybe this is more like maybe early August, late August, because we have grapes, and we have certified organic berries and grapes, and we have 70 different crops, and we have 25 customers. And it's been a long journey to get to this. I mean, it started out with just 3 of us, 4 of us, and now we have 50 to 90 students show up on Thursday nights. So I spend like 2 days cooking, 3 days cleaning up, and then I start cooking again. So anyway, so we're completely self-funded, including over 200 paid internships, summer internships through the sale of fruits and vegetables. And we're currently in a campaign to have an endowed position, which means you get a bunch of money, goes into an account, and then that would be permanently funding what I've been doing for free, but as an instructor level position, which I am an instructor level position, but I teach classes. I mean, I have a job I'm supposed to do. So, and I teach classes, but I recruit from my classes to the farm, and I recruit from the farm to my classes and the internships. And it's like my iron triangle of student recruitment and retention, which used to have value at the university, but now they're really like looking at numbers and saying, well, how does this make any money for the university? I was like, 30,000 students have come to the student farm. It's integrated in all my classes. Anyway, I'm not going to complain about it yet. I mean, I'm complaining about it, but that's not what I come here to do today. Anyway, I just wanted to show you that I grow fruits and vegetables, and I've learned, and in 25 years, I learned about a vegetable per year. And now I can put together 25 vegetables in a weekly box, and we go 30 weeks of fruit and vegetables right around the beginning of October, we go to every other week. So we did like 20 something, 25 or something, three during the summer, and then we'll go all the way through the new year with every other week. And they get smaller now, but they're still pretty big. I mean, they're the biggest they've ever been. So anyway, so I grow vegetables and I've studied soils and I have a degree in soil science at Oregon State University. So anyway, I've also not I can talk about me forever here, but I'm also the a former president of the Oregon Society of Soil Scientists. Done that 3 times, and that's a group of soil scientists in Oregon. And there used to be soil science societies all in every state, and there are not so many anymore. But it's super fun. Really enjoy that. Anyway, um, what else can I tell you? So yeah, what we want to talk about today, though, is we want to talk about soil. But actually, I think I've been in this room before. I think 15 or 17, something like that, years ago. Have you ever heard of Soil School? Did you hear that? It's in the West Multnomah Soil Water Conservation District. They host this thing called Soil School, and there's like 100 people show up every once a year. And I've been doing. And the first meeting was here in this room, like 18 years ago, and I've been to everyone as the keynote speaker for 18 years. And I was just like, wait a minute. And how did the humanist group find me? Just curious. Huh? Yeah, really? All right. So that's what it is. Okay. And we were downtown or something. We met there. So that was one, right. Was that where we were? Yeah. Yeah. Anyway, so great to be here. Thank you. And a little bit I've learned about this group already. It's sounds like home to me. So this is good. We're all humans. There you go. Let's start there if we can. So anyway, what I want to talk about today is what soil is, how it forms, what nutrients are, and how it works. I mean, how it actually works to store nutrients. And I mean, it's all about soil. And I don't just mean like, food and stuff. I mean, everything, our entire existence is completely tied to the soil, literally. We are, every atom in this room, these were trees up here, right? And those are plants that lived in soil, and that's where they live. And so everything you eat, every atom in your body has been through the soil system billions of times already. The fact that you are not soil at this moment is a temporary condition, and it's almost over, folks. And I don't mean this talk or this day. It's a flash that we're here. And yet here we are today together at this time together. Really, we actually are here. This is not virtual reality. This is not AI. This is actually I. Okay. It's like real I. And we're here together today to talk about something that is ultimately real. It's the ultimate. And I was in the music business and I had a great career doing that, but learning about soil has changed the way I just see everything. And I hope today to change the way you see reality today. Okay, so buckle in because we're going in deep. I would argue that you are soil now. You're a four-dimensional complex habitat, self-organized natural body, a living thing. That's what soil is. It's a self-organized natural body, a four-dimensional complex habitat. I don't know if you know, I had to run outside. I went and got some soil, which is right out there. There's a chunk of it. And it's pretty cool actually, because there's worm castings on the top of this one. They're little worm, they look like little turds. Look at that. You see those? Start looking down. You see those little things that kind of look turd-like? Those are what are called worm castings. And I have some soil right here, just outside of this building. I don't know if you know this, but a single pinch of soil contains over 1 billion living organisms. In this pinch of soil right now, we know that, we can measure it. It's a fact. Science, right? I heard the vibe and hear about that. That's what this is, right? This is evidence-based information. And you know what? 50, 100 years ago, we didn't know that. And yet now here we are together at the same time in the history of the cosmos. At this particular time in the history of the cosmos, we actually know stuff that mostly we didn't know until pretty recently in our existence as humans, right? I'm not pandering to the humanists. This is my normal rap. So anyway, so I'm pandering to the humans. Okay. And to these guys. And it's not just a billion of one thing. There are literally tens of thousands of different species in a pinch of soil. And we can measure that. It's kind of the age of biology right now. And they really can designate those by genetics. They know who they are because of what they do. But 99.99% of them, they don't know who they are or what they do. They know they're together, and together they have these complex symbiotic relationships that do all this stuff. They're basically cycling carbon, energy, and mineral nutrients and stuff like that, right? So I dare you to remember that, because it's not just that pinch of soil. It's this one too, and it's this one, and it's every pinch you will ever touch again on the planet Earth. I dare you to remember that. I dare you to forget that. Okay? Your assignment is to never forget that. Okay? Until you go back. And it won't be long now, folks. I mean, what we live, 70, 80 years if we're lucky, 90, 100 if we're not, whatever. And then that's not very much time in the history. Oh, well, so I just say, I don't know why, just argue with her. The thing is it washes down the drain and it goes somewhere and it goes back to the whole earth. I mean, it really does. So we'll talk more about that in a little bit. But where every atom in your body was actually once inside of a rock. I mean, every atom in this room and everything you will ever see ever again was either mined or grew. It came out of rocks. And then what grew actually came out of the rocks too, the atoms. I mean, it's like, that's what you're made out of. And there's 118 different elements in the known universe that we know. And that's what everything's made out of. Everything's made out of that. And that's what rocks are. I had to go outside and get a rock. I have a couple of different ones here. And you should start looking at rocks. They're different colors, right? And they're made, what this is just chemicals, right? And these are made at high pressure and high temperature. And under those conditions, that chemistry can happen. And then when they cool, they crystallize. And they're made out of elements. And the different crystals that are inside, say, like a granite countertop or something like that, those big crystals, those are just different minerals. And a rock is just a collection of minerals. And minerals are different atoms from the elements in the periodic table. And rocks, here's most people never think about, ironically, because they go to their graves never having considered reality, that rocks dissolve in water. And see, because we don't live long enough as individuals to really understand that, or even as a species or as a modern species, especially with the kind of thinking power we have to. I mean, whole mountain ranges have come and gone on this planet and dissolved away. And it's like, yeah, but don't we like make pyramids out of it and stuff? 4,000 years is nothing. Even that's a flash. It rains in Egypt a little bit. And those pyramids of Giza will completely dissolve away sooner or later. And sooner than you think. I mean, whole mountain ranges are dissolving away right now. And if you don't believe me, think of this. Different minerals, some dissolve fast and some dissolve slow. And the ones that dissolve fast is the simple one at lunch today. Just take a little table salt, put it on your hand, and that's sodium chloride. That's a mineral. Sodium chloride with ionic bonds, and then lick it. And it takes about that long, and it dissolves. And that's a mineral that dissolves super fast. In geologic time, it's like instantaneous. And then and some dissolve fast and some dissolve slower, but they all eventually dissolve. And the next thing to dissolve is the molybdenum and the calcium and the phosphorus and the zinc and the iron and the aluminum and all the things that make up the elements in your body were dissolved out of a rock first, and then they were traveled, they were stored in the water and on clay. We're going to talk about that. And then a plant took it up, put it into the tissues, and then you ate it, or your mom did, or you ate an animal that ate the plant, you drank the milk, whatever. That's where the nutrients come from. That's what every atom in your body got there that way. That's a fact. I mean, that's just a fact. And every atom in your body is going back there. It's just, that's a fact, as has happened billions of times already, right? So you really are a soil organism. I mean, you really are. I'm not just saying that to be kind of cute. It's a fact. And those elements, like I actually have some water here. Let's do a little demonstration. Ready? Okay, here we go. We'll pour a little water on this rock. You ready? Did you see that? You see that? Let's do it again. Oh yeah, see that? Tiny little bit of that rock just dissolved away. Really? Like really? Okay? And yeah, tiny amount. And what's the first thing that dissolves out of a rock, do you think? Salts, right? And a little bit of potassium chloride or something. There's salts in these. And a tiny little bit, because there's a little bit of hydrogen ion in the water, which is a source of acidity, and acidity sort of attacks the structure of the rock. And rocks are actually very unstable at the surface of the earth. They're most stable under high pressures and high temperatures, and where there's no water. And all of a sudden they come up as lava or as a pluton or erosion or uplifted, plate tectonics lift up. That's the real nutrient cycle, is plate tectonics and volcanism, because it brings it up higher and then it dissolves and it goes down in the valleys, and that's where we farm. Well, that's where the mammals live and stuff, is on the plains and all that. So the first thing to dissolve out of this are the salts. If I was outside and I did this right now, and it's happening right now, it's raining, there's rocks out there, and a little bit of salt is dissolving off of those rocks. You know where that water goes? It goes down in the soil. So now there's a little bit of salt water, very, very, very dilute. And that moves down every time it rains, goes a little further down, goes a little further down. Pretty soon it gets to the water table, dissolved salts. And then that is connected to a tiny little creek or something. And that drains down another little creek that goes to a river, that goes to the big river, goes to the big river, that goes to the giant river, that goes to the ocean. And that's why the oceans are salty. Yeah, because that's where the and the next thing to dissolve a rock is the molybdenum, the calcium, the phosphorus, and the nutrients. And where do they end up? In the ocean. And that's why there's life in the ocean, because the nutrients dissolve off of the land and travel down the drainages and end up in the ocean. And that's why there's sharks, because that dilute water has nutrients in it, and it's very dilute. And so there's these tiny little plankton that are called phytoplankton that live near the surface of the ocean. They use the energy of the sun to like build their tissues from those minerals, dissolved minerals. And then a little zooplankton eats that, and then a fish eats that, and a bigger fish eats that, and pretty soon it's a shark. And that's why there's life in the ocean, because that's where the nutrients come from. And the uplift of plate tectonics, which right now, this plate that we're standing on right now, is uplifting at about the rate, give or take an order of magnitude, that your fingernails grow. And it's lifting up because there's a plate slipping off out under the ocean off the Pacific, and it's ramming into this continental plate, which is lifting it up. It's a highly simplified view, but you kind of understand what I'm talking about. And that's being lifted up. And if it's lifted up and then it rains, it dissolves down. And that's the real nutrient cycle. And there might be elements in your body that have been through that cycle already on this planet. Been a rock that lifted up and then dissolved down and became a plant or an animal or a bacteria or a fungi or the billions in a single pinch or whatever. And that has happened over and over and over. And then the next thing to dissolve is the molybdenum and all that stuff. And that's what ends up in the ocean. That's why there's life in the ocean, right? Same thing happens in the soil pores. Because the pores, I don't know if you know this, you probably do. You know this little, and it's not a great demo. But you know that little bridge of water, you can see it between your fingers. You've done that, right? You've all taken a bath and played with water and said, what is going on? Why is that? And that's called capillary force. And small pores hold water against the force of gravity because of capillary force. And capillary force is quite a strong force compared to gravity. And actually, the size of the pore, the break point between a macropore and a micropore, large pore and small pore, is how does it hold water or not? And that's 0.08 millimeters. And at 0.08 millimeters, if it's bigger than that, it drains under the force of gravity. So large pores drain under the force of gravity, small pores hold water against the force of gravity. And when you water a plant, you've noticed this, you water it till the water comes out the bottom. And then you lift it up, and drains a little bit, but it's got a lot of water held in there. So you don't have to water it every day. You water it when it starts to feel lighter, right? But you'll notice that a bunch of it drains out because the big pores are draining. And when the big pores drain, you know what's being pulled in behind them? Air. So when the soil is draining, the soil is breathing because the billions in a single pinch need air for the same reason, oxygen for the same reason you do. So the soil is breathing when it's raining, and the water is dissolving the minerals, releasing the nutrients in the water, right? And then it's stored in solution in a tiny little ocean that's this big. And that's where the nutrients are, okay? It's where the soil isn't, is where the activity in soil is. It's in the voids, the spaces between the sand, silt, and clay-sized particles, the spaces between the rocks. That's where the water is, the air is, the nutrients are, the bugs are, the roots are. I mean, that's where everything happens, is in between. Nothing happens inside of a rock. And this is just a giant piece of sand or silt. It's just giant. But these get smaller. Look at this thing's round. You know why? Because it was ground down. And it's getting smaller all the time. Eventually, this will be completely gone. It'll be a piece of sand size. And sand, according to USDA, sand is anything from 2 millimeters down to 0.05 millimeters. No matter what's made of, metal, plastic, whatever. It's a sand-sized particle. Mostly it's minerals, right? Because that's what's the most abundant stuff on the planet. And then the silt is something that's 0.05 millimeters down to 0.002 millimeters. And that's just a smaller piece of sand, if you will. I really shouldn't use the language like that, but it's Sunday, right? We're just talking like people here. And then clay is a particle that's smaller than 0.002 millimeters. We're going to talk about it in depth because we really want to know, because that's the one that's super important. Okay. So just quick review, right? Rocks dissolve in water, so the nutrients come out, go into the ocean, or stored in soil water, and plants take it up. And you eat the plants, or you eat the animal, eat the plant, or your mom did, and that's why you're here. And every atom in your body has been through that process billions and billions of times, over and over. And so you really are a soil organism. You really are part of the earth, not just sort of like cool way, but literal way. You are literally part of this whole thing. That was once a tree. Sooner or later, that's going to be gone. That's either going to burn or it's going to rot, which is the same thing. It's oxidation. And the making of a plant is called reduction chemistry. It's an endothermic chemical reaction. So we got to talk about that. So I have a piece of vegetation right here. And it looks like a cedar, right? This is some sort of oak, right? So these are plants. So we talked about minerals and rocks and stuff like that, right? And what, these are a lot of water in them, of course. If you dry them out, what are they mostly made out of? Huh? Sugar, who said that? Yeah? Okay. I got a gold star for you. Hang on. Yeah, you bet I do. Yeah. Sugars. Yeah, okay. Oh, so you already know. I'm up right there. Go to the bar, you get a free drink. Just say, hey, give me some distilled sugar. Carbohydrate, carbon, mostly made out of carbon. That's what these things are made of. And carbon, yeah. And that's what this tree, that's what this wood is. In fact, most of you probably know that plants take in carbon dioxide and they give off oxygen. And most people think they're breathing. No, plants don't breathe carbon dioxide. They eat it. Plants eat the atmosphere. And there was a time not that long ago when people didn't believe in carbon dioxide because it's invisible. You know, but people believe in visible things. um, but they really fought that kind of thing because it's just you show me, except some things they don't seem to have that the capability of arguing against, but not to get all humanist on you. Um, but I'm super pleased to be here, I have to say, because it's not always like that when I do these talks. So I can't have fun like that. I get in trouble and things like that. And hey, the Lord likes soil. I can spin this any way you want. I mean, we don't know where it came from, honestly. So why not, if it helps you. Um, anyway, so what this tree is mostly carbon. Where did the carbon come from? The atmosphere. No, almost always the right answer, but in this case, from the atmosphere in the form of CO2. And so in order to take carbon dioxide apart and put it together into these tissues are carbon to carbon bonds. You got to take apart the CO2, and then the O2 kind of goes off, and the carbon gets put together with hydrocarbons, and they get put together into sugars and complex molecules, but mostly carbon, right? And what this is, in a way of not really correct way of thinking, it's sort of like compressed air or something, but the carbon part of it only. But a huge amount to build a tree and roots and flowers and seed casings and every plant you've ever seen. That's what they're made out of, mostly is carbon. Carbon comes from the atmosphere. And in order to take apart carbon dioxide and put it together into carbon to carbon bonds to make a chair, or over there too, or a piano for that matter, takes energy. It doesn't just passively happen. I mean, you got to take apart the molecule and put it together into a new one. That requires work. It's not passive. So it takes energy to do the work. And where does the energy come from, humanists? The sun, the sun, the Son, Father and Son, and the Holy Ghost. Uh, the Son, the S-U-N. I mean, you're going to worship something. Yeah. It's pretty worthy. It really is. I mean, and it's the nearest star. What it is, it's the only star we have that has a name like that. It's called the Sun. And it's a 93 million miles away. There's a ball of energy that is giving UV radiation to this planet. Tiny, tiny, tiny little sliver of it hits this tiny little planet. The rest of it goes off into, space. And this little bit, these photons travel 93 million miles, and there are these molecules, structures in here, photosynthetic parts, and it excites an electron into a higher orbital. When it drops down, it releases a little bit of energy, gets captured in a molecule called ATP. And ATP is a molecule that stores the energy of the sun in the chemical carbon-to-carbon bonds in it. And then that, according to the DNA instructions that are in every cell in our body, which themselves are made from dissolved minerals, phospholipid bilayers. I mean, the phosphorus on the outside of the DNA molecule came from dissolved rocks, and they store information on them. And according to that information, that little ATP molecule can go anywhere in the cell and release that energy to break carbon dioxide apart and to build a piece of wood. And so in the carbon to carbon bonds, in this wood, in this thing here, in that leaf, in that piano, is the energy of the sun at the time of photosynthesis is stored in there as chemical energy. For real, from the sun. And a simple demonstration, and I usually do that, but I just didn't think I would do it here, is I bring a match, which is a piece of wood. And if you get it to 451 degrees, what happens to wood when you get to what happens to books when you get it to 451 degrees? It burns. Fahrenheit 451. You know what a book is? It's a piece of wood that when you look at, you have a psychedelic experience. I mean, it's like, talk about wild. in your mind, all those images that are in your mind, that's all energy from the sun that's doing that. You are an expression of sunlight energy. Yeah. And you're just a bunch of wet rocks. And you're too big, so you can't tell what's going on in a single pinch of soil. And it's almost over. So, hope you're having a good time. But we're talking about something. This is real shit. I mean, this is not just some made up stuff. This is like, the actual tested hypothesis, the whole thing, right? And it's just textbook now. We call it textbook because people invented writing because they invented agriculture. Or the invention of agriculture, which is a technology, people traveled with the seasons and followed the animals. And so they only could store information through songs and dance and stuff like that, stories. But to be able to write it down for the next generation to build upon, I mean, that comes from agriculture. And of course, agriculture is a complete disaster, but for the planet, but it's been pretty good to us. Let's just be honest. And so, what I was talking about. Oh yeah, the energy. To get it to 451 degrees, it bursts into flames. Because to do that, it's an oxidation chemical reaction. It's an exothermic chemical reaction. Making this as an endothermic chemical takes energy from the sun to build these tissues. And then to go back, when you burn it, when you get this hot enough, it goes back to CO2, water vapor, heat, light. That's the energy. Stand by a fire. That's the energy of the sun that is stored in the chemical bonds of the wood that is now being released. Came in as UV radiation, goes off as infrared heat into the universe. But for the moment, it's in this carbon to carbon bonds, right? And what you have to do, you have to overcome the activation energy, you add heat, energy for it to then become the oxidation chemical reaction called burning. And when that happens, it releases enough heat to keep the chemical reaction going. And it's a chain reaction until you run out of wood. And then it burns out, the fuel is used, right? And where did the carbon go? What's in the fireplace after the fire? What's left over? Ashes. And what is ash? Minerals. Who said that? Yeah, man. All right. That was a great group. I'm glad I came up here. Look at that. Here, keep that too. There he is. So A+ students. Sometimes they're in the back of the room. They are. Usually they're up here. And then there's the B's. And there's the rest of us, which is where I belong. But I was a D- stoner rock and roller in high school. I barely graduated high school. They shouldn't have graduated me. I didn't go to school till I was 30. But that's why I have 4.0. Well, not because I'm smart, because I know how to manage my time. I have 3 degrees and a 4.0. Just because I always actually sat in that seat, second row right here, and I got an A. And I sat in that seat because I was a little superstitious about it, and I got straight A's because of that seat. So there you go. Hope you're getting your A today. All right. I'm just going to give you a gold star anyway, just because. Okay, here's one on your. There you go. Stars upon ours. Okay. Okay. So, and that heat, that energy, and the ash is left over. Those are the dissolved minerals that were taking up the roots. And you'll notice how much wood you can burn and not have that much ash because there's not that much ash in there. But there's some in there and it doesn't burn. And what happens to those minerals? They go back and they get taken up by the next generation of plants. But the whole system is driven by solar energy. And every blink of your eye, every breath you're taking, every pump of your heart is energy that was harvested from the sun by plants that lived in soil. That's a fact. Every moment that you're having this experience of reality, so that you can remember how I started this sentence, so that by the time I get to the end of the sentence, you know what I'm talking about. That's all because of energy from the sun that is storing that in electrical impulses in your brain. Just every moment of existence. This is you're in it, and those are facts. It's getting a little out there, but but it's something to get out there on because it's kind of like, wow. And once you start to get that, man, you can't unget it. So I'm sorry, it's too late now. You can't go back. And so, and so that burning is the energy that's being released, right? And the same thing happens in rotting. Like there's some leaves out there right now. See them out there? They're going to be gone. Maybe they'll pick them up. Maybe they'll just rot. I can see last year's debris down there. I can see like organic matter kind of scum on there from 2 years ago. And just start looking down. And what's happening there is those are burning at a lower temperature because of bacteria and fungi, the billions in a single pinch. That's what the bugs are doing, the billions in a single pinch, is they're lowering the activation energy necessary for the oxidation chemical reaction called burning to happen. But it's exactly the same chemistry rotting is. It's just that these bugs, they ooze out their external metabolism. They're oozing out enzymes. And what enzymes are catalysts, and the catalysts help the configuration of those molecules to align in such a way that they don't have to get to 451 degrees, they can get to 51 degrees, right? And then the oxidation chemical reaction happens, and a little bit of energy is released, and the bugs get it. And that's what eating is. That's why you eat. You get the energy from the food, and the food gets the energy from the sun. And that energy, what happened? Look, there's a hole here and there's a hole here, and there's a tube going through your body. And that is the external world that's going through the tube. You don't want to get that mixed up with, inside of your peritoneal cavity or something, right? So it's a tube, and that has billions in a single pinch in there. They're living in the lining of your gut. Microbiome is living there. And they're the same thing. They're doing the exact same functions as the soil. In fact, it's the same stuff. Fungi and bacteria live in the linings of your gut. And what are they doing? They're oozing out enzymes. They're dissolving organic matter and oxidizing it, and lowering the activation energy necessary for the oxidation chemical reaction called burning to happen at like 97.5 degrees instead of 451 degrees. And what comes off of the fire? CO2, water vapor, and heat. What's coming out with how do you get a fire to burn hotter? Air. Everybody, oxygen specifically. Everybody, oxygen in. CO2, water vapor, heat out. Oxygen in. CO2, water vapor, heat out. And you're literally, with every breath, you are respirating, and that's what that is. It's you're burning. And you use the oxygen to do it. And the bugs need the oxygen to do that chemistry. And what's left over in the fireplace afterwards? What's left over that's going into every blood? It's in your bloodstream? Minerals, dissolved minerals. And where are they going? Wherever the DNA tells them to be used to build the structures, to make the cofactors, to do the whatever. And there are literally trillions of biochemical reactions happening per second in your body. And they're all being driven by solar energy because you're adding it. You don't want to know what the answer is? Doesn't even matter what the question is. You want to know what the answer is? Add organic matter to your garden soil. Because when you're adding organic matter, you're adding carbon from the atmosphere and energy from the sun. You're feeding the billions in a single pinch, which ooze out enzymes that dissolve the organic matter to make the nutrients available to the current generation of plants. And when they die, that's how it works. It's almost like we live in a giant solar system. You know what I mean? Yeah. Like a rocky planet with water and a star. And plants have figured out a way to eat the atmosphere and using the energy of the star to make life. And we are just completely just live on. In fact, we have the soil going through us. We carry that. That's why we can be giant. Inside of you is a secondary mineral in the shape of a human skeleton that's mostly made out of what? Calcium. Where did that come from? Dissolved out of a rock. And then you ate a plant. It had calcium in it, right? And it just holds this huge, giant macroorganism. And you're just like a robot. And you're chewing up, increasing the surface area and delivering it. And that's why you get hungry for certain things, because your gut microbiome tells you need sugar, you need protein, you need whatever. And so all these decisions you're making are just being handled by the soil that lives inside of you. It's like we're an inside out carrot. I mean, a carrot is a tube that goes into the soil and pulls nutrients in, where we just kind of flipped it inside out. We carry the soil around inside of us and live around it. It's like, and as long as we keep adding organic matter, everything is fine. Because you know what, the microbiome will ultimately eat, don't you, when you stop eating? Like when? It's almost over, folks. Oh my God. Well, maybe I should get to my first slide. You ready for it? Here it is. Let me get it. Here it is. What's going on here? There it is. Soil. All right. But we had to talk about all that before we could really talk about soil. And I do have, 10 minutes, maybe a little bit more of time to talk about some things. And I don't know why that's not working. It's kind of a pain in the ass. Who cares? Yeah. So I don't know if you know this, but there's 20,000 different named soils, just like plants and animals. And there's an app for that. I know, guy comes to talk to humanists, cracks on his phone. But it's an app. It's called the Soil Web app. And wherever you are in the United States of America, you can say, get my location. And it's called Soil Web. It's one word. And it'll tell you what the soil is mapped as. Because we mapped the soils of the United States over the last 100 years. Because people knew about this stuff. Most people didn't, but the people who cared about the future did. Kind of a, outdated concept. But and it's available on your phone. And this one it's just called urban land, and it hasn't been mapped. You know why? Because it's been urban land so long that they didn't spend the money to map it. But it's related to soils that are nearby. And I could show you how to do that at some point. But wherever you are, you should always be checking the soils. There's 20,000 different names. So this one's called so this is the 20,000 soils belong to one of the 12 soil orders. And here's an example, one called an aridisol. What do you think that means? Dry, right? Is there a lot of water in an aridisol? No. So are there a lot of nutrients being released? No. And so it's a very different kind of soil. And in fact, see this layer right here? This is like if you dug a hole and looked at the wall, it's called a soil profile. If you look at that, this here it rains about 12 inches or 6 inches a year here because the soil is only 12 inches deep. Because when it rains 6 inches, it goes down and the salts go down about a foot and then it stops raining. And that keeps happening over and over and over. And I got a layer of salt here. So it doesn't rain enough there for it to ever get to the ocean. So the nutrients never get to the ocean either. And there's not that many nutrients. And so you got to live there. You got to look like that. And that's what a native plant is a plant that has adapted to the subsurface conditions as much, if not more, than the above ground conditions. And so this is a really salty soil, really alkaline, and there's not a lot of water, and the nutrients are being very carefully sequestered away by these plants because they don't want to let them go because it takes a long time for them to be released. And we're here, we have what's called a mollisol, mollisol. A mollisol, like to mollify is to soften or to molars or to chew, right? This is like chocolate cake. This is like 2 feet deep. This is almost scale. And you see all that dark stuff? That's organic matter, what's left over, right? So, and what that mostly is roots that grew in there and then died. Grew in there and died. And that's, what is that? What is a root made of? Carbon from the atmosphere, energy from the sun, and it's injecting it into there. And this is like the most important agricultural soil on the planet. It's called a mollisol, and that's where we grow agriculture. That's why we're a superpower, because we have more of that than anyone else on the planet. In the Midwest, the United States, in the Mississippi Valley, where floods happen, and there's lots of nutrients because that's where the water is. But it's not so wet that the nutrients wash away to the ocean. It's just the right amount of wetness that look, there's some salts down here, but there's all the nutrients following it because the salts dissolve first and go the furthest. And so all the other nutrients are here. And that's all being driven by solar energy, the billions in a single pinch there. And what do, they're using enzymes that are releasing the organic matter. They're helping the organic matter oxidize so that the nutrients are available to the next generation of plants. And the roots themselves are shaping soil. It's a self-organized natural body. As the roots go down, they're adapted to the soil texture, the percent sandstone clay, and they make it better. They make more macropores that go deeper. A channel goes all the way down here because it's a connected pore from a root. And then when that plant dies, that back to CO2, water vapor, heat, and ash. And what's left is a big macropore. And so the next time it rains, it goes a little deeper. And so the next generation of plants can recolonize the old root channel and go deeper. And they keep doing that and doing that. And pretty soon it's called a mollisol, where there's energy and carbon at depth and a lot of biology. And that's all cycling nutrients, energy, and carbon happening here. And that's what grassland soils are. And grassland soils didn't exist until about 20 million years ago, because grasses are kind of a modern plant. And they're mostly the dream of a dog, because canines were the first organisms to hunt in packs, or at least first mammals to hunt in packs. And before that, animals just walked around, just ate whatever, vegetarians just eating, and they would eat and indiscriminately. But then once you started having pack behavior, you get herding behavior, because the animals that didn't figure out herding behavior got picked off. And the ones that figured it out, passed on that behavior. And the old and the young and the sick get out to the edge of the herd, and the strong ones in the middle and whatever. And so they would come as a herd, and they would eat everything to the ground. And then the only thing that can survive that is grasses. Because you eat a tree down on the ground, it's not going to be a tree, because they grow out of their tips. Where grasses, they just keep sending it up feverishly like an antenna. And then the animals eat it down. They're stimulated to send up more and put more roots in. And so this is called a mollisol. And so this behavior changed. And that happened about 20 million years ago. So it's a modern soil type. And we always go to that one. Let me see. I just want to show you this. So this is the global soil regions on the planet. And I want to draw your attention to mollisols. 21% of this North American part of the North American continent, the United States, is in mollisols. That's everything you need to know about why we live in a modern technological society. Because they who have the advanced soil agricultures have the advanced technologies. That includes thermonuclear weapons to control the planet. Talk about that's because it allows for specialization. Yeah, you might be gardening, but you're not growing the food. You're growing a little bit of your food. Somebody else is a specialist who's growing the food, so you could become a specialist at making printers at Hewlett Packard, for instance, or becoming a brain surgeon. Well, I don't know. I'm just pointing at you. Or whatever. Every one of you is a specialist at something, because we're not all just following the animals and the seasons. We've written it down, and we can make this world like it is, for good or for evil, including thermonuclear devices. And there's one other place on the planet Earth that has about the same amount of mollisols as we do. Russia in particular. That's what the Cold War was all about. They who have the advanced technologies can control the planet and leverage it, the technologies. And that's what the hot war is all about. Ukraine is about 90% mollisols. And they want it to be part of the big bear again, because it's a really important agricultural asset. And look where the trouble places. Here's the iridosols and the insectisols, dry places. And you might think, oh, what about the tropics? Not really good at all, because it's so wet and so hot there that all the nutrients are gone, or locked up in the above ground biomass and just being feverishly conserved in the tropical rainforests, which are super diverse. They're kind of like the diversity in the single pinch, but above ground in macroorganisms. And by the time a leaf falls in the tropics, before it hits the ground, it's being ripped apart. Before that thing goes to bed at night, it's being eaten by something else, and be pooped right on the surface, on the root. It gets sucked back up. Then none of the nutrients get away, because they're all gone. And you cut down the tropical rainforest, and the soils are terrible. And they'll never come back. They never will come back. Because when this used to be in a different part of the planet, where it was when all these evolutionary selection events happen under different conditions. I mean, we have these really red soils around here. Ever see them? You kind of go up in the uplands where and those are like they're like tropical soils because they were formed under tropical conditions, and they're paleosols. It's not a soil order, but it's a type of there's a bunch of soils that are called paleosols, meaning they formed under conditions that no longer exist. And we have those here. And our state soil here is named Jory. I don't know if you've heard of that. It's the red one. When you go up near the wineries, you'll see it. That's red, like red. So anyway, just wanted you to kind of, what this is a map of political power is what it is. And they who have that political power have no idea where the power actually comes from. And that's the problem. Upside down world, backwards land. And we should show this to our political leaders and say, what is this? And they should say a map of soils, or it's a map of political power. And then they would, and that's what it is. And so that's what I mean. It's everything. It's not just plants and animals and wood and food. It's everything that we know is directly linked to the soil. We just got a couple more minutes here. I do want to show you. Here's tropical soil, right? It's mostly rust because iron is the most abundant element in the Earth's crust, or one of them. And when iron dissolves out of a rock, it oxidizes and becomes rust, and it's very durable, and it doesn't dissolve again because it was made as a secondary mineral at these temperatures and pressures and moisture, and so it's a very durable. And that's why barns are red, because this is the most abundant secondary mineral that is protected. It doesn't oxidize because it's already oxidized. So you mix it in with linseed oil and you put it on wood, and that protects it from getting wet, and it's got a layer of rust on it. And that's what happens once a piece of steel rusts, it stops rusting, because it's got an iron oxide shield on it. And so, and you can grow stuff in them if you bring in lots of nutrients and stuff. And this particular one is called Molokai, one of the 20,000 different soils. And this is the taxonomic class for it, in case you were wondering. It's a very fine kaolinitic isohyperthermic typical eutororax. Come on, let's say it together. It's the first time you've ever said a soil, one of the 20,000 different, so ready? Let's start from the top. Ready? Very fine kaolinitic isohyperthermic typic eutororax. Ends in ox, it's an oxisol. Tropical soil. Tor means hot. Eutro means it's hot all the time. And it's a typical one. And it's isohyperthermic, meaning it's hot all the time. And it's got kaolin, which is a type of clay that doesn't store a lot of nutrients. And it's very fine because it's like fine texture, like a clayey soil. So it stores a lot of water, doesn't drain very well. And so it's a very fine textured, really hot all the time, typically hot all the time oxisol, right? And so that's one of the 20,000. And it's called Molokai, which is just the location, but that's the taxonomic class for it. We have in the Pacific Northwest slightly different color scheme, but of the 12 soil orders, we have 10 of them in Oregon, which is extremely, I think it's the only state that has 10. And that's because look at different geology. We got the Cascades. We've got uplifted marine sediments out here. We got a valley where all the nutrients go. And that's why this is the seat of political power. That's why Salem is the capital. That's where all the capitals are, is where the good soil is, because that's where people lived. And that's where the power is. And it's usually near a river, so you can transport new stuff. That's why. And then this is dry country, and this is all volcanic ash out here. And there's just enough moisture out here eventually that you can get some good agriculture out here, wheat and stuff like that. And down here it's just like, wow, here get down there, Christmas Valley and stuff. It's just like insane. It's just a beautiful place, but dry. And the mapping of this, so there's 20,000 different named soils in the map. So I do want to show you. Oh yeah. Well, let's just show it just for a second. And I'll explain what we're doing. So we're going to go to the California Soil Resources Laboratory, which is the same thing as the app on your phone. And you can put in an address and see where the soils are. And this would be useful for anyone, and especially the people online. You can do this. You can just go to the California, write this down, California Soil Resources Laboratory, I don't know. Maybe this is like a disaster. Okay, see if you can find it. In the meantime, and in between time, questions? We didn't get to clay, but I can come back sometime. Oh yeah, there one right here in the front row though. Yeah. All right. You can't get to it? Okay.
Okay.
We'll do it some other time. Yeah.
Well,
Fire away.
yeah.
We didn't get to talk about clay, but I will just quickly. What clay is when the rocks dissolve and then recrystallize at the surface of the earth, they can only get these little particles, these crystals can only grow to 0.002 millimeters. And because there's little substitutions in the clay crystal, there's a negative charge on clay. There isn't a negative charge on sand, there isn't a negative charge on silt, but there's a negative charge on clay. And kaolinic clay doesn't have much negative charge, but young clays like we have around here has a lot of charge, and the negatively charged particles store positively charged nutrients. And when you put fertilizer on, they get stuck electrostatically to the surface of the clay mineral, and that's they don't wash into the and become ocean and becoming sharks. They stick around in quantities of nutrients stored enough so that macroorganisms, terrestrial macroorganisms, can assemble. If it wasn't for the negative exchange complex on clay, there wouldn't be macroorganisms on terrestrial ecosystems because all the nutrients would be in the ocean. So kind of an important thing. We'll talk about it some other time.
We don't have a lot of time left for questions, and I have a feeling that the answers are going to be long. So let's get started. Who's number one?
Question. So there's a lot of concern about carbon sequestration. And one of the problems with storing carbon in forests is forests can burn
and rot
unintentionally. And I've thought that storing carbon in soils is a more secure way. What's your impression?
Well, that's the answer is organic matter.
Yeah, organic matter in soil. What happens is even when it rots, a lot of it goes back to CO2, but some of it doesn't. Some of it stays behind as black stuff, and it coats the particles. And in fact, I was just talking about clay. Organic matter, the kind of black stuff, has negative charge on it too, and it stores nutrients on the exchange complex. Anyway, that organic matter gets captured inside of low anaerobic environments, inside of clay and stuff, and it sticks around for thousands of years. And as long as you don't disturb the soil and add oxygen through tillage or disturbance, it stays there longer. It's when we till soils, we're adding oxygen, which makes the fire burn and the CO2 leaves the system. Yeah.
We got a question on Zoom from
Rob. Can't resist asking, what's your take on hydroponics?
I'm an organic advocate, and it's quite a controversial subject in the world of organics because it's a soilless media. And organic, by definition, one important definition, it's a soil-based agriculture. Just came back from the Tilt Alliance talk in Spokane, which is why I wasn't sure I was going to be able to make it here because my flight got canceled because they shut the government down, blah, blah, blah. Got home at 3 o'clock this morning, and it was a great talk and everything, but I had this long conversation with a bunch of people about it. It's a big controversy about it. And there's a group called the Real Organic Group, and they are saying, no, shouldn't be in there. But it's not just like, and I just learned this, the roots are not just dangling in some water. But I always say, where do the nutrients come from? They come from somewhere else that maybe wants them or could use them, right? So, there's that. A lot of infrastructure, but maybe in an urban core, it makes sense. But nothing is going to be everything, right? And so a lot of the hydroponics is done in cocoa fibers and stuff like that, where you have a porous media still that's becoming soil because bacteria are starting to live there, and pretty soon it's starting to organize, and pretty soon it's kind of soil pedogenic processes happen. Pedogenesis means the making of soil. So I'm kind of like wishy-washy on it, and I think that it's you got to have rules. And so they can figure that out, whether it's allowed or not, maybe come up with a better way of defining what hydroponic is. Because right now it's like, well, what is it? There's a lot of different ways it can be done. And so, and that is, and just because we don't like hydroponics doesn't mean that people should starve to death, or whatever. So, I mean, in the future, we're going to have to make hard decisions about that. So, kind of a whatever answer, I guess.
Question 2 here
Big agribusiness uses petroleum-based fertilizers.
Yep.
And has produced lots and lots of food very cheaply.
Yep.
What impact does that have on you? I mean, you being
Well,
Mr. Soil.
And, well, I mean, I think scale
Is a really important part of all these conversations. And certain crops, it's you grow them at large scale, but certain crops a lot more energy intensive. I mean, there are organic farmers. I mean, organic farmers, they don't use a lot of herbicides, so they do a lot of tillage. So they're burning a lot of fossil fuels, right? So it's not like they're right, we're wrong, they're wrong, we're right. It's like what actually makes sense. And it's true to get the nitrogen out of the atmosphere, which is something that a bacteria can do in conjunction with legumes, which is why we grow legumes as a cover crop, is they can take the nitrogen gas, invisible gas, out of the atmosphere, break the triple bond, turn it into nitrate, feed it to plants. To do that in an industrial model takes a huge amount of energy because you got to get the gas at high pressure and high temperature to make nitrate fertilizer. So the embedded energy in that kind of fertility is very high. But they're using drones and they're not maybe they're not using herbicides because they're doing no-till conventional, so not a satisfying answer, I'm sure, but it kind of just depends on the scale, what you're growing and where you're growing it. I mean, this whole like regenerative agriculture, if you saw the movie or whatever, it's kind of this kind of American model of agriculture. It can't be put everywhere. I mean, if you're living in the desert, it's a different kind of regenerative agriculture. So there is no one answer, I think, is the most important thing, especially in soil, because it's just different. There's 20,000 different named soils because there's nowhere on the planet that's the same. There's enough that you call it a soil type, but you go to the East Coast, it almost has the same, but they're different soils. So I don't know if there's a follow up or something, or
To use these
yes,
petroleum-based products.
it does.
And this, I don't know where this is going to go, but maybe not to my boss, but it changes pH and to become more salty over time, and that's bad for the billions in a single pinch. So you're challenging the microbiome and maybe pulling out some important functions and trying to replace it with a kind of chemicals. And soil is a living thing, and at some point it gets to a point where that collapses as a living thing, and then you're really stuck only using chemical control and energy expensive ways of farming. Yeah.
Well, that also answered one of the questions we had
2 for 1
through
Wow.
Zoom here. Number 3 here.
Let's go to the home garden,
Mhm.
our gardens and our yards and
Yep.
stuff.
Good.
And turning the soil.
Yeah.
So you start your garden and you are turning the soil.
Sure.
And then you hear that, maybe you shouldn't disturb the
Right,
soil.
right.
So where
Yeah,
are we?
so again, it's
Of course, but minimizing disturbance is the goal, not eliminating disturbance, because agriculture, by definition, is minimizing diversity. You want to have corn in a field this big for this room. That's minimum diversity, right? And so what we do is we have a crop rotation that creates diversity in time, not in space. A forest has 80 or a couple hundred different plants living simultaneously together. It has diversity in space, but a well-managed plot or organic or garden, you're always moving the plants around so that just about the time that the plants, the diseases and the nutrient problems and the insect problems and when you disturb the soil, when all that happens for tomatoes, just about at the end of the season, they're going, oh, I can't wait for tomatoes next year. And all of a sudden it's like, what? Garlic? And they put it in over winter and the disturbance regime is at a different time. And so and then after that, it's broccoli, and then it's carrots every year, and you're creating diversity in time. So as far as disturbance goes, the disturbance regime of those different crops is different. Like carrots, you start super early, and you don't really disturb the soil for tomatoes until the end of May. And so you're just minimizing this. And sometimes you don't need to disturb it at all when you're transplanting a 4-inch pot in a soil that you got straw over and you just didn't till it that year. You just make a hole and put it in there and close it in. So that's minimizing disturbance by being mindful of when you can. If you're going to put in carrot seed, which is this big, it needs fine soil. Soil has to be in a very fine textured soil. So you got a disturbance, but you don't have to turn the entire garden into a carrot bed just because you're putting in a couple rows of carrots. But where you are growing those carrots, sure, till the shit out of it, get them going, whatever. But don't do the whole garden that way because you don't need to. The bigger the seed is, the less it needs to be processed. You could put fava beans in, which are that big, just kind of push them in, and then just put some straw on it and they'll grow. So you see what I'm saying? Not a super satisfactory answer in that there's not a rule. This is not like I'm going to tell you, follow this list. Because what if I write it backwards or you misinterpret it? You got to think about minimizing disturbance where you can.
Okay, number 4.
My dad's farm had a lot of clay on it, and you're saying that clay
That's good, but when you have a lot, it stays wet.
Stores goes down. What would it take? In other words, we knew that.
You wanna know what the answer
maybe
is?
that farm wasn't very saleable.
What's the answer?
Ever.
Add organic matter.
What would it take?
It would add organic matter. Grow organic matter there for a dozen years in cover crops, and it will become
Less tight and it will have better drainage because there'll be old root channels.
My dad didn't know that was a big.
because they were taught, by Earl Butts to
Garden fence post to fence post or whatever because they're trying to build the nation so they could win the war or whatever. You know what I mean? So there were trade-offs to that kind of agriculture, and now we know what they are. But clay soils, if they're some of clay soils, the water tables are high, and there's nothing you can do about that. So it's not a great place to try and do mechanized agriculture, but it might be a good place as a wetland that has function, and it might have more value as a semi-wild land or something, or some other way of managing the land for value. Not a satisfactory answer probably either, because there are no answers. Everything is a little different, and you have to think about these things. But now you know what soil is and how it works. You can derive those answers. And what soil is habitat. And it may not, what works in one place is not going to work in the other place because the soils are different. One more?
We got time, but
And I do want to
4 or
show
5
one
more minutes.
Okay, and I do
We have a
want to
very,
and
very
you're gonna
slides to show again, if you don't mind, Dave.
at some point or somebody. But but we can take another question in the meantime.
we have a very important question.
Excellent.
From Zoom. What's on the side of the speaker's hat?
Actually, it's like it's a hand holding a bowling ball. Yeah, it's got flames on it.
All right.
Because I'm an international rock star. I don't know if you know that, and I perform for the last 45 years in a band, and we had gold records and stuff, and we still perform quite a bit. Not as much as because we have jobs and lives and everything, but we still go and do shows. And I go down to Brazil. We do 8 shows. We're doing that in December. But we did a benefit concert at a bowling alley that was like Rock and Bowl or something like that. And they paid us to come, but it was a big fundraiser. And this is the guy sells the hats too, and I just grabbed one, and it's got the logo on it. So it looks like that because it's rock and roll, but it's got the 2 fingers in a ball, right? Because it's like it's on fire because it's rock and roll. So
Okay.
great, thank you.
Question 5.
Well,
Possible.
Well, that's what the first thing they looked for on Mars was?
Water?
Nope. Huh? They were looking for clay. Because if the only way clay can form is if rocks dissolve and then recrystallize. And if there's clay, that means there had to have been water. And if there was water and there's clay, there might still be water. And if there's water and clay, that means that there's nutrients can be stored at the surface of the earth. And maybe the water was there and it's gone now, but it was there because they found clay. And they can clearly see, rounded aggregate rock that looks just like this. And this was, polished in a river. And so they know that there was large movements of water there, but they were also just wanting to see if there was. And so if there was clay and if there was water, that means there's a possibility there'd be similar kind of processes that would lead to life. And so that's what they were looking for first. So the water's not there. It seems. I'm sure there's frozen water underground and stuff like that, but at the poles, and probably was a giant oceans there and it all blew off or something, in some sort of cosmic event or maybe a collision with some larger body or something like that. But we're never going to live on Mars. We can't even live here. I mean, and everything's here. And even if we did live there and grew some lettuce under a dome or something, that's not living. And we're just not adapted to being on another planet. Psychologically, we couldn't, what would it just be? I don't think we're prepared for that, what that would mean. And it wouldn't be this. Maybe we become the aliens finally, that little green men or something. What we should do is develop GMOs in us so that we can photosynthesize by sitting out in the sun. Well, there's got to be I'm sure there's some sci-fi books that have come up with that. Maybe probably even read it once or something. But then we literally would be the little green men. Yeah, man. And we could just sit outside and we wouldn't have to cut everything down and till the soil all the time. We could just kind of live as part plant, which, seems to be a strategy for building soil. Yeah.
Did you have?
I have one more slide.
Yeah.
Soil's habitat. Here's clay. Look at clay has a negative charge on the surfaces, and here's what clay looks like, 100,000 times magnification. And it's got negative charges all over it. It stores positively charged nutrients. Yeah, I just want to show you all these. And so read this with me. Here is net negative charge due to isometric substitution of the secondary mineral called clay is the reason that soils store nutrients. And that's why every nutrient in your body was once on the exchange complex of clay and or organic matter once. Anyway, here's what I wanted to get to. That's right here. So you can buy these shirts. And 100% of the profits go to funding my student interns. Yeah. And so it's called soilforward.org because it's soil forward, right? And it's for the kids. And they got to live here after us. And, this is like, I teach them everything that we talk about in a 10-week course. They take my organic farming and gardening class. They take my soil management for organic production class. 50 to 90 students come out, student farmer every week. Yeah, every week. Right now, they're still there. I mean, in the Sunday mornings are the best because we don't serve supper and only like 20 people show up, and they're the best people because it's pouring rain and they're there on Sunday morning. So it kind of self-selects for like 15, 20 really good ones is a little easier to manage than 90 but they can broad fork up, an acre in 25 minutes or something. It's crazy. So, and I have these shirts and I also have them in Klingon and in Vulcan. So, depending on your mood, which we're going to wear, and or if you know some Klingons, I'm sure you do. Probably mostly Vulcans here, frankly, but but we have both. We have dual identities, right? And again, I sell enough of these shirts to fund internships that I wouldn't be able to afford otherwise. And we have 13 internships a summer, and they're $1,000 a month for 3 months. So it's like, $30-some thousand. And we sell about $30,000 worth of veggies, but that doesn't include buying the seed and the food and all the stuff that we do to keep this farm running. And like I said, I'm a volunteer myself. I don't know if you use QR codes, but this is what people do these days is they take a picture of that and then takes you right to the website. But please, won't you go to Soil Forward? I'm not trying to like sell a product to you. I'm trying to sell it to someone else. And you can help me do that by buying these shirts. Okay. And this is excellent. I'm glad you mentioned that because to find out, this is actually, if you go to that website, and this is a different slideshow because I forgot my computer today. I can believe that because I left it. Anyway, it's just the way it worked out today. But if you go to Soil Forward, on the homepage right now is this effort that I'm trying to get this endowed position. And and it has a little description of what that is. And there's also some donation page just to give money to help pay for students too. And we also have Start Seeing Soil bumper stickers and stuff like that. But if you don't want crap and you just want to give money, that's, we don't need more crap, honestly. But this is okay crap. But I will promise you, if you wear one of these, you've got to be mindful that this is SOIL in the Klingon alphabet. And just so you know that, because people are going to say, what's that? And you're going to say, oh, it's soil in Klingon. I say, no, that's SOIL. It's the English word in Klingon. And because people really speak Klingon, they can get a master's degree in that, and they write in it, and they were serious about it. And the only reason I have these shirts is because the band I'm in, we were the first band to use digital sampling, and we sampled a lot of the original series of Star Trek. And so we became part of the Star Trek world, and we were on a Star Trek cruise by George Takei. He invited us to go, and we played back-to-back cruises, and we all did other stuff too on the cruise. And one of the things I did is I did a big soil talk. Like, if there's life on other planets, where's it come from here? Like 250 people in the room at a bar, and everybody's drinking. It was super, super fun. I got to about an hour into it, and I said, well, we're kind of running out of time. So I said, keep going. So I kept going, but I made these shirts in advance. And I sold like $6,000 worth of these shirts. So I still sell them because they're kind of cool, and it makes an impression. But this endowed position is for a half-time position. And obviously, I won't bore you with this too much, but it's $1 million to do that, to go into a foundation. And then in perpetuity, it will fund the position I do for free after I'm dead. It'll still happen. And we'll have a student farm that was started by 3 students who complained, who wanted experiential learning opportunities to teach themselves outside of the classroom. And that's probably the real threat. And also to learn about organic and sustainable agriculture, because that's growing. And we just talked about controversial stuff, and they need to know that stuff, because that is going to be a part of the future. Is sustainable agriculture in a more directed way, not just on the fringes. It isn't on the fringes anymore. It was 35 years ago, but that's how change happens. It's a selection event. So we're selecting for a different kind of egg, or we're not going to make it. And they have to live in this world after us. And so I'm putting the heat on now. Yeah. This is about we kids, all right, in the future. So, and I've got $360,000 already. So I'm trying to close the gap so that I can be the half-time guy for the next 3 years, and then hire the next person and make sure the PD position description is right, and that it doesn't just go off into some OSU thing that somebody finds someday and uses it for something else. You know what I mean? So if you do have that kind of money, it doesn't have to be that kind of money, but if you really got something, you got some investments or something that you'd like to go into something that's going to actually do something.
Okay,
I'll take your money. It's not for me. It's for the future. Okay. That's it.
Thank you so much. Definitely a rock star.
Oh yeah. Well, I got the rock. All right. Thank you so much. It was really fun. I hope you learned some stuff. I always learn something. So one last thing. Okay, before we leave, we're gonna sign in now. This is like a swearing in ceremony. You ready? Put your hand on your heart. This is the cult part of it. Like, I promise
I found
on my honor to do my best to find out what soil type is under my house. One of 20,000 different soil types. And to get the Soil Web app from my phone and go outside today and pick up a pinch of soil and say 1 billion. Amen. Okay?
Oh, yeah.
So, so that's all. That's all I got for you.